Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology. So in this, the friction, wear and lubrication are very crucial parameters. So these three plays important role in engineering tribology. So we have learned about theory. Now in this session, we will see the questions related to this wear and surface treatment. The wear topic, the question bank of wear and surface treatment. So in examination, how they will ask in exam in this type of questions related to this wear and surface treatment. The first one is explain the term wear and elaborate different types of wears. The wear refers to the gradual removal of or deformation of material at solid surfaces due to mechanical action. So there is some material loss. So whenever two surfaces are in contact due to the friction or cutting or sliding, it is a common phenomenon in mechanical systems and structures. So it will leads to decrease the performance of product and the lifespan of components. So various forms this wear can occur. So it is depending upon the conditions. So how many types of wears are there? We will see in this next coming up slides. So there are some types here mentioned here, abrasive wear. So what do you mean by abrasive wear? This type occur when hard particles or hard turbulent corundums force against. So here some force means against this move along a solid surface. So the abrasive wear, whenever the hard particles are present, are against this force, leading to material removal. The types are two body abrasion, abrasive particles are fixed, and three body abrasion, thus abrasive particles are loose. The examples sandpapering and erosion of pump components by sand particles in water. Next, adhesive wear. So this type of wear caused by the formation and breaking of adhesive junctions. Like adhesive junctions are called as cold welds between two sliding surfaces. The mechanism is when two surfaces slide over each other, material transfers from one surface to another due to adhesion. Example here galling, scupping and fretting. So the corrosion wear exerted by the chemical or electrochemical reaction with the environment leading to material removal. So the different types of corrosions already studied in the corrosion topic. The mechanism is here oxidation or other chemical reactions weaken the material, which is then removed by mechanical action. Examples rust formation on steel surfaces, degradation of metal surfaces in acidic environments. Next, fatigue wear. So the caused by repeated loading and unloading cycles. So whenever the component is subjected to repeated loads or cyclic loads, it leads to formation of cracks after some iterations of cycles, cracks and subsequent material removal. The mechanism is here the surface fatigue due to cyclic stresses results in fitting and spalling or crackling. Examples here rolling contact fatigue in bearings, gate tooth fatigue. Erosive wear. Description is caused by the impact of solid or liquid particles against a surface. The mechanism is particles hit the surface with high velocity, causing material to be removed by cutting or deformation. Examples are erosion of turbine blades, wear in the pipeline transporting slurry. So these are examples for this erosive wear. So whenever the solid particles, the blade, so example take these turbine blades are subjected to solid and liquid particles against the surface. So some material will be removed due to this impact. In this case, the erosive wear will be occurred. Next, fretting wear. So in this type of wear occurs due to small amplitude oscillatory motion between two contact surfaces. The mechanism is here the repetitive motion causes surface degradation and the formation of wear particles. Examples fretting in bolted joints, contact surfaces in electrical connectors. The cavitation wear is caused by the formation and collapse of vapor bubbles in a liquid near a solid surface. So the mechanism is the implosion of vapor bubbles generates shock waves that remove material from the surface. So examples damage to ship propellers and pump impellers and hydraulic turbines. So these are the cavitation wear examples. Just explain briefly about surface fatigue wear and how it is controlled. The surface fatigue wear, how it is controlled. The surface fatigue wear occurs due to repeated cyclic stresses acting on the surface of a material, leading to the initiation and propagation of cracks. The surface fatigue wear occurred due to the cyclic stresses, the repeated stresses acting on the surface. It leads to initiation of a crack, and over time these cracks grow and intersect, causing material fragments to detach from the surface. This type of wear is commonly seen in rolling contact situations, such as in bearings, gears, and cam follower systems. The mechanism is the micro initiation, the micro cracks form on the surface due to cyclic loading. Propagation, these cracks grow with continued stress cycles. The material removal means the eventually the cracks intersect and lead to the detachment of material particles, resulting in fitting, spalling, and flaking of the surface. The examples are fitting on a gear tooth, a spalling in a ball and roller bearings, and cracking in railroad tracks. Next, control of surface fatigue wear. So the here material selection. So by selecting the material, you can control the surface fatigue wear. So use materials with high fatigue strength, toughness, and hardness. So before selecting the material, you should be tested. So those materials are having high fatigue strength. So you can select those materials for your application. Not only fatigue strength and also toughness and hardness. So employ surface treatments like carburizing, nitriding, or induction hardening to increase surface hardness and resistance to crack initiation. The surface engineering apply coatings such as chrome, nickel, tungsten carbide to improve surface hardness and reduce wear. Use short peening or laser peening to introduce compressive residual stresses on the surface. which helps to resist crack initiation and propagation. In a lubrication, so ensure proper lubrication to reduce the friction and wear by selecting the proper lubricant and proper lubrication system. You can reduce the friction and wear. Use lubricants with additives that form protective films, reducing direct metal to metal contact and distributing loads more evenly. Next, design improvements. So optimize component design to distribute loads more evenly and avoid stress concentrations. So use large radii at corners and fillets to reduce stress concentration. So the stress concentration is very important in when designing the components. So whenever the sharp corner is having that component, suppose example, the component is like this. Here sharp corner is there. So here more stress concentration will be occurred whenever this one is subjected to force. So to avoid this stress concentration, you have to use radii at corners and fillets. Instead of this one, you can use like this. So this is a fillet with radius R. So by using like this, you can avoid this type of stress concentrations. So the design improvement, the optimize the component design, also very important factor in this minimize the friction and wear. Regular maintenance and inspection. Perform regular inspections to detect early signs of surface fatigue, such as micro cracks or fitting. So, scheduled maintenance and replace worn components before significant damage occurs. So, regular maintenance whenever is required, the maintenance you have to monitor it daily, frequently, and regular inspections detect some indications, the failure indications. So you can avoid by inspecting the components. Next, control the operating conditions. Avoid excessive loads and speeds that can increase stress on the surface. The implement proper alignment and balance in rotating machinery to reduce uneven loading. By addressing these factors, surface fatigue wear can be significantly reduced, the leading to longer component life and more reliable mechanical systems. This one, so it can leads to uh, increase the life of the component by avoiding this controlling the operating conditions like loads and speeds. Next type of question is write short notes on fretting wear, surface fatigue wear, and erosion wear, and percussion wear. So fretting wear. So fretting wear occurs due to small amplitude oscillatory motions between two contact surfaces. This type of wear often arises in mechanical joints where there is a slight relative motion between surfaces under load. Next mechanism is the repetitive small improvements cause surface degradation. This leads to the formation of wear particles and potential agitation. So this type of friction generally occur where this type of wear occurred in bolted joints, splined shafts, and electrical connectors. The prevention is use of lubricants to reduce friction. The application of surface coatings or treatments. Designing for better fit and reducing relative motion. Next, surface fatigue wear. So already we have studied in previous slides. The surface fatigue wear is caused by repeated cyclic stresses on a material surface, leading to the initiation and growth of cracks, which eventually result in material removal. So here mechanism is uh, micro cracks form due to cyclic load. The cracks propagate and intersect, causing material to fall or flake off. So commonly, this type of surface fatigue wear occurred in rolling elements like bearings and gears. Mechanical components, the rolling elements like bearings and gears are frequently uh, subjected to this type of wear. So how to prevent this type of wear? Using materials with high fatigue strength and surface treatments like carburizing or nitriding. Proper lubrication to reduce stress. Regular maintenance and inspections. Next, erosion wear. This one also we have studied. Erosion wear is the result of mechanical action where solid particles or liquid droplets impact a surface, leading to material removal. The mechanism is high velocity particles or droplets strike the surface, causes cutting, deformation, or material displacement. Seen in pump impellers, turbine blades, and pipelines transporting abrasive slurries. The prevention is use of harder, more erosion resistant materials, applying protective coatings, the designing components to minimize the direct impact zone. So these are the prevention methods. You can control the velocity and the concentration of erosive particles. You can control. You can minimize by by using these all these prevention methods. You can control the erosion wear. Percussion wear. These type of wear generally occur due to repetitive impact or hammering actions on a material. So leading to deformation, material displacement, and eventual wear. So whenever the component or material is subjected to repetitive impact, there is this type of percussion wear is occurred. So how to avoid it? So to avoid repeated impact causes surface deformation. Material may crack and spill off due to the constant hammering. The common in tools like hammers and anvils, and in machinery subject to repetitive striking actions. Generally, in a mechanical workshop, the common tools like hammers or anvils are continuously hammering or continuously repetitive load. Prevention using tough or impact resistant materials. Applying surface hardening treatments. Properly designing components to distribute impact forces evenly. The regular maintenance to identify and mitigate early signs of wear. So the regular maintenance is required. Already we have covered in the previous slides to identify and mitigate early signs of wear. These brief notes highlight the key aspects of each type of wear and common strategies for their prevention and control. So next type of question is describe briefly between Harchar's theory and adhesive theory, adhesive wear theory. So Harchar's theory of adhesive wear is a generally widely recognized model that describes adhesive wear, where wear occurs due to the formation and breaking of adhesive junctions between two sliding surfaces. So the basic principles of this the Harchar's theory, the adhesive junctions where when two surfaces come into contact as per it is microscopic eye points on each surface interact and may form adhesive bonds. During relative motion, these adhesive bonds can shear, causing material transfer or wear particles to be generated. The wear volume. The Archer's wear equation relates the volume of material worn away to the applied load, sliding distance, that is D, and the hardness of the softer material H, and a dimensionless wear coefficient. You can write V is equal to KL multiplied with D upon H. So there V is the material worn away and applied load L, and D is the sliding distance. H the hardness of the material. The key components are here wear coefficient K and applied load. So this the dimensionless factor, this one wear coefficient, it gives effectiveness of their shear. They typically determined empirically and can vary widely depending on the material fairings and environmental conditions. The applied load is the normal load applied to the contact surfaces. Higher loads generally increase the adhesive wear. Next, sliding distance. The total relative motion between the surfaces, greater sliding distances result in more wear. So hardness, H, the hardness of the softer material in the contact wear. Higher hardness usually leads to lower wear rate, as a harder material are more resistant to deformation and adhesion. Next, assumptions are the model assumes that wear is proportional to the applied load and sliding distance. It also assumes that the wear debris is formed mainly due to the adhesive forces between the contact surfaces. So, what are the applications of this Archer's theory and adhesive wear theory? So, Archer's theory is used to predict wear in various mechanical systems, such as bearings, gears, and sliding contacts. You can predict the wear by using this theory. It helps in selecting materials and designing components to minimize wear and extend the service life. So it helps to minimize the wear and also improve the service life of the components. The limitations are there. The theory simplifies real world conditions and does not account for all factors influencing wear, such as lubrication, surface roughness, and temperature. It is primarily applicable to metal on metal contact and may not accurately predict wear in non metallic or composite materials. So, by using this Archer's theory, engineers can estimate wear rates and design systems to reduce adhesive wear, improving the reliability and longevity of mechanical components. So, by using this theory, all this theory, you can avoid the wear and also improve the life of the components. So that every engineer should use these theories to predict the wear before designing a components. So these are the references I have taken for this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.